Hello, this is a short video about specifications. It's actually from an online class that I took, and I've put that recording, shortened that recording down for you. It involves making up the specifications for a wheeled product, a toy, or a number of different types of toys, just to so we can see an example of how to make up specifications. There's also some, it finishes off with going through some examples of other specifications and how they can be made. So I hope you learned something about specifications. All right, what I want to do now is I want to talk about specifications and get you guys sort of sorted out a little bit and understanding specifications. I think you probably already do understand specifications well, but just in case, let's just spend some time on it. All right, so on the screen, I've got four types of wheeled objects. Okay, wheeled transport objects, wheeled toys, wheeled things, if you like. Who's ever ridden a dragon board? These ones on the right-hand side. Has anyone had a go at a dragon board?
Nope.
Okay, they're two separate things. They've got two wheels underneath. They're sort of like two roller skates, except roller skates have four wheels and the wheels are fixed. Whereas on this, the wheels are caster wheels. The wheels are these type of wheels in the middle here. That's a caster wheel, okay? A roller skate has wheels more like a skateboard. And so these dragon boards are very difficult to ride, and they move all around like my hands are. And so they're very tricky. You've got to sort of do a motion like this to ride them. And they're very fun though, but it's easy to break your back and your ankles on those. A scooter, it's a different mechanism for steering. It has actually a steering wheel, okay, and you can steer because it has a direct response steering, and that makes this one very different from the other three, because a ripstick has the caster wheels again, but it only has two, but the deck can hinge. So its steering mechanism is moving your feet like this, just like you would on a snowboard if you've been snowboarding and you want to do heel side or toe side on a snowboard. And then a skateboard's very different again because it has trucks, and trucks are like this here in this picture. There's a picture of a truck. See the two yellow bits? That's rubber. And so if you press down on the right-hand side, someone got a question? If you press down on the right-hand side here, then you actually steer this thing. Okay, so caster wheels spin around like this. Skateboard wheels are fixed, and they steer by like the heel-toe thing. And you notice on this here at home, or one of the kids, we've got three, I always put this design modification on. And the design modification is this chock of wood that I cut around the back, and I recess the bolts so they don't scrape. So as I'm skateboarding, or as someone's skateboarding, okay, then the chock sits at the back so they can lift the wheel up at the front like that, and the back will scrape on the road, okay, I should have brought the skateboard with the chock on it rather than Sydney's. There's the bottom of Sydney's skateboard. Look at the designs, okay? So there's a fair bit of aesthetics that's going on there. We'll talk about that in a minute. So this skateboard, or the chock, is a braking mechanism. None of these things have braking mechanisms on them, okay, except for a scooter, which may have a little braking mechanism at the back. All right, so if we're talking about these wheeled objects, what would be the specifications, do you think? Let's hear from you guys. What are the specifications that we need if we were going to make one of these successfully?
Safety, like make the skateboard safe enough to ride on and not like break or injure.
Okay, yeah, we need to worry about safety. Okay, so it must be strong enough for us to stand on. That's a safety aspect. If it breaks, it's not safe. It also must have a grippy area where you put your feet, yeah? If it's not grippy, you're going to slip off it. So that would be safety. The other thing that could be in regard to safety is it must be made of those durable materials that are robust and that are not going to just fall apart. So bolts might need to be put on with lock nuts on them, etc. Okay? Okay, so safety is a good one. What's another specification that would be required here?
Mommy, can you help me make it?
Anyone else? It must have wheels that roll. and they must probably have bearings. I should have brought a bearing. I should get a picture of bearing in here, actually. A bearing is a set of little roll of little metal round balls that are packed in grease and in a ball bearing, which allows it to spin very, very freely. So these must be good quality, hard plastic wheels that allow it to spin freely so that you can actually move. The axles must be strong. What other specifications would we have?
Aesthetics.
Aesthetics, yeah, we mentioned that. Okay, so it must be good. Look at this skateboard here. It's got this really cool set of designs on the top of it. My son's put stickers on the bottom of his board. I showed you the aesthetics on Sydney's. So aesthetics are important because why are aesthetics important? Lizzie, were you going to say something? No? Why are aesthetics important, do you think?
Aesthetics are important to ensure that the client likes the product, and if the client likes the product, then the chances of them using the product will be increased.
Yes, exactly. And they're going to be our target market, aren't they? So it's really important that we get these right. Now, I don't want to go over this too long because you guys are probably pretty good at specifications already. So tell me to stop if you've got this sorted. Okay. Now, if I just what I'd like to do now is let's just have a look at the
If it's 11, do I do
specifications that I made up for you, or that we've started already, and that I want you to keep working on. So if you come here now to the specifications page, you will see that there are some already there. Okay, we've got steering, we've got be able to stand up on it and grip. We've got the wheel spinning, we've got aesthetics, and we've got customer, we've got manufacturing. Do we want to make it out of different things? We've got the environment. Do I really want it to be made out of plastic or something? Okay. And then we've got cost constraints. This is not an exhaustive list. I would like you, and this may be a little bit different to what you've done before, I would really like you to get now into the habit of putting in this box here on the right. How can I test it? Okay, so how can I test that it's cool looking? I know that this is designed for, say, 8-year-old kids. I'm going to go and ask 10 8-year-olds or 20 8-year-olds, what do you think of this design? And I'm not going to say to them what the design is. I'm just going to say to them, do you like this? Or, you know, what do you think? And then get their responses. So I can actually test whether my aesthetics are doing it. And if you can't test something as a specification, if you can't say and write down how I'm going to test it, then maybe it doesn't have any right to be a specification. Because really, a specification needs to be tested. Otherwise, you know, we're not going to know whether it's successful or not. So it's just a good idea to start thinking about how it's tested. And then when we get to criteria, D, what's going to happen with our tests? We're going to rip them to, you know, they're going to be so easy to do once we have that happening. So it's a good idea for us to have a go at that, you know, understanding how we would test it from the start. Now, as I'm talking, I'd like you guys to open up this wheeled objects sheet that I'm showing you now, which I've shared with you in Google Classroom, and you can type some stuff in there. But I'm going to go back to here, and I'm going to go through now some other specifications because I want to just show you. I want to show you some other ones and just talk to you a bit more about specifications. Okay, so. Can I pan that around? I can, you beauty. All right, so we've talked about aesthetics, we've talked about cost constraints, got customer requirements, we've got environmental concerns, size and weight. You know, skateboards and wheel instruments, they need to be pretty light, and our chairs need to be light. And I'm doing this deliberately not as a chair so that you can think about this as a concept, then apply the concept to the chair, okay? So even though this might seem irrelevant, it's actually good for you to do it this way. Material requirements. So in the chair, let's just talk about the chair for a second. Your material requirements are 600 by 600 square of 9mm plywood. That's all you're going to get. And you have to fit your chair into that box. And that's another reason why AutoCAD is going to be really helpful. So you're only allowed to use 9mm ply, and the laser cutter and hand tools. Okay, so that's what you'd put in there. The function of your chair.
Oh yeah,
For a certain age group, blah 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 blah. You know, it's going to be comfortable. It's
should
going to
work
be packed down
now.
and packed up,
I
etc.
was on the
Joining methods. That's all part of the thing. Okay, so I just want to race through now a few different specification samples for you, so that you get a bit of an idea on what they are. So here's another one. Let me just bring that across a bit so you can see more of it. Okay, so in here, this is just a different format for these: aesthetic requirements, environmental considerations, etc. Performance requirements. Okay, so how is your chair going to perform, or how is this wheeled object going to perform? What are the material requirements? Manufacturing, we're going to let you use a laser cutter and AutoCAD, and that's going to be your process. Okay, if you have really big trouble with AutoCAD, I'm happy for you to use Inkscape or some other program to draw in. Okay, I don't care if you don't use AutoCAD, but I'm just suggesting AutoCAD because I can support you more with that. All right, so you're seeing some different types of specifications here. None of them have the testing stuff on the side, but they may talk about testing in here. Okay, so safety, performance, etc. Here's another one. So here's the specifications. Here's the justification for how I'm going to use it and why I'm going to do it. All right. Now, I've shared all of this with you. This work here, now this page is from Miss King, and you've had Miss King before, and she's taught you wonderfully about specifications, I'm sure, and because this came from hers, and it's a really good sheet. So this PowerPoint is in your folder in online learning, and you can go there, and so here and just refresh this if you need to. So there's the list. All right, let's have a look back and see now if we're adding anything in here. Has anyone started doing any typing in here? No? You don't feel like you can? What about if we put down here manufacturing requirements? All right, now let's just pretend instead of the wheeled object, we're doing the chair. So that would be the laser cutter, all right? And it would be AutoCAD or drawing package, all right? And then, you know, we could write down there, the test is that, yes, we did use it. Okay, so some of these boxes won't be fully used up, but, or, you know, fully entered, but they'll be there quite a bit. Now, cost constraints, is there any cost constraints for us on the chair?
No.
No, there's not, but there is in a way, because we're saying to you, here is the piece of wood, all right? And so we've bought that wood for you. So yeah, there's no cost constraints, but we've constrained you in another way, okay? So you could write down there that the cost constraint is the cost of that piece of plywood and some paint and some sanding and, you know, some materials like that. But that's not too bad. All right, any questions about specifications?